Hello everyone, welcome to part 4 of this recitation, wherein we'll be talking about the rest two types of errors, the time issues that you might face, and then the memory issue. Sometime after debugging all the syntax errors and your model is running, you see that it takes 40 minutes to train an epoch. Ideally, it's supposed to take 10 minutes, and you're worried about how you need to improve this. This recitation will cover that. First, the things to check would be check if you're using the GPU. That is one of the most common mistakes that I did in the beginning. And also increase your batch size as large as your GPU does not complain with out-of-memory errors, from 32 to 64 to 128 and so on. The best practice is to check the data loader and then the training loop. Most of the iterations happen here because you're going through each data sample one by one to load it. And in the data loader usually is fine if that is finished and the data has been loaded. But in the training loop, if you see that there is a part of if each iteration of the training loop takes a lot of time, if you see that if that takes a lot of time, you probably want to investigate that. Another trick is to use mixed precision. Here, we will be covering in one of our hackathons on how to use different types of data types, such as float 32 and float 16, in order to avoid making use of more memory than what is required, as float 16 would be faster than float 32. More on this later. And using the time module to time which part of the code takes long is also a good idea. Next, coming to the memory issue, the model trains normally within 10 minutes and so on. But after the 30 epochs, you see that a common error that has occurred is that the computer, the RAM or the GPU or the VM that you have runs out of memory. What to do in that case is that if you put too many things on the GPU, you might see something such as the CUDA out of memory. Things to try here would be to reduce the batch size, use the mixed precision, and also read the tutorial of each homework tools before read the write-up properly, and also read the tutorial on how the mixed precision works, but we will be giving a hackathon in this later as well. And finally, during validation and testing, you would want to turn on torch.inference. What this does is that it disables gradient calculation, which is only needed for backpropagation during training. This reduces memory consumption, and hence it's a good idea to turn that on. Also, emptying the cache of torch.CUDA helps reduce fragmentation of the GPU memory in certain cases. Forgetting to move data to the GPU for training also might make the running slow, and you might get an error such as expected objects of device type CUDA but got device type CPU. Here you would want to move even the model and all the data variables that are there that are used for training to the device, and make sure that all of this is on GPU before the training begins. There might be a mismatch between the locations of different data. You can find out what this mismatch is by printing .device. PyTorch gives that useful tool, and then move it to the GPU or the CPU, and then go from there. And that covers most of the debugging tricks that we use. Good luck and have fun in the course. Thank you.